Hello guys, welcome to this channel. In today's video we'll be talking about set theory, and under set theory we'll be first look at the definition of a set, and we will look at the representation of a set. After that we consider the types of sets, and we look at the properties of a set, and we look at set operations, and the last thing we consider is Venn diagram. So if you are preparing for examinations like WAEC, NECO, or JAMB, set theory is a topic in mathematics that you must understand. So you must understand it very well, so as to be able to solve any questions and answer any question correctly that deals with anything set theory. So I want you to subscribe to the channel if you are just joining us for the first time. My name is Mr. Israel, and by the grace of God I have been teaching mathematics now for the past 6 years. So subscribe to the channel, like our videos, and share them with your friends, so as to get more videos and more tutorials dealing with mathematics from anywhere in the world that you are watching us from. So without wasting much of our time, I want us to go straight to the topic of today on set theory. So you're welcome back. Let's try to explain the definition of a set. I believe the word set is not a strange word. Set simply means a group of things, collecting a group of things together in one place. That's the meaning of set. So, and if you look at the board, we have different objects. We have numbers 1, 7, and favor with a name of a person, alphabet A, 9, 5, and 2. Now you can see that 3 sets have been formed. The first set here is a set that I named A, which comprises of 3 elements, 1, A, and 5, which is placed within a curly bracket. And the second set here, set B, is set favor, A, car, placed within a curly bracket. And the third one is C. The elements of the set are 2, A, and 7. So we can divide a set. We divide a set in mathematics as a collections of well-defined objects. The object here can be numbers, can be alphabets, can be things, can be anything whatsoever. So when they are collected together and placed within a curly bracket, they are known as a set. So you identify the set, you name the set. As I have named the set now, this side we have set A, which is an alphabet. So the name of the set is always in a capital letters, and the elements of the set are placed within a curly bracket. So that is how you can denote set. So we have some notations and symbols you need to be conversant with. Like for example, this symbol that looks like E here. This one stands for element. It means element. It means that you are saying that 1 is an element of set A. That's what it means. And this one also telling you that A is an element of set A, and also 5 is an element of set A. Now look at this 9. You can see that the E is coming with a cross, telling us that 9 is not an element of B. That is what it means. When you see this E symbol, it stands for element. So you can see now that 5 is an element of A, and 1 is an element of A. So that's why we write it there as an element of A. So if you are getting much value from this particular lesson of today, please you like the video and comment in the section below. You just type set theory. I understand set theory. Now we are now going to look at ways in which we can describe a set in mathematics. So in mathematics, we can describe a set in 4 ways. Number 1 is by words, using word statements. Using word statement. For example, if you look at this set A here, that is described by factors of 12. So that is example of a word statement. And this word statement just use word statement to describe the set. So factors of 12. That's the set A is set of factors of 12. Then you can also now describe a set by listing out the elements of the set. So if you now further want to see all the elements of the set of factors of 12, you can go ahead and list them out. You can see that 1 is an element because 1 can be divisible, 12 can be divisible by 1, 2, 3, 4, 6, 12. Those are the elements that are factors of 12. And this type of set is called a finite set. We are still getting to that. So we can also describe a set using algebraic notation. Algebraic notation, we using alphabets to represent numbers. So in this case, look at another set here. A is x semicolon means that x is such that x is from -1 is lesser than equal to x lesser than 8. It's telling you that the range of x is from -1, and -1 is inclusive in the range, and it stops at a lesser than 8, which is 7. Lesser than 8. So if you are listing out the elements of the set, you start from -1 and increase the element up to 7. So these are the ways you can actually represent sets. So you can also represent sets using Venn diagram. Venn diagram is a pictorial representation of a set. So Venn diagram is actually a pictorial representation of a set. When you see a circle, it means a set, collections of objects or elements of that set will be placed within the circle. And when you see the universal set will be represented by a rectangle. Now every element within the universal set, every subset of the set of the universal set will be represented as a circle inside the rectangle. And any elements, so there are, like in this case now, this circle represents the Olamide's family. So it's showing us a picture. Within the family we have the father, standing for this letter F, the mother, Esther, David, and Gideon. So there are 5 members in this set, in the Lamades family. So all of this set. So a Venn diagram gives us a pictorial representation of the set. It makes set to be represented in form of pictures that we can see, we can visualize, and we can analyze quickly, and we can use it to solve problems. I hope you understand. So there are 4 ways in which we can actually represent sets. We can use word statements. We can list them out, the elements of the set, one by one. We can actually use algebraic notation, and we can use Venn diagrams to represent the set. So in the next lessons, we'll be looking at the types of sets, because we have different types of sets. So we'll be looking at the differences between those types of sets. We'll be looking at how those sets are being represented for you to know. So we are taking it step by step so that we can easily understand and have the whole idea of a set before we can actually now begin to solve related problems and deal with sets. Thank you. Alright, you're welcome back. Now let us talk about the types of sets. Types of sets. We have different types of sets. And the first one is the universal set. Universal set is always denoted by this symbol here. The symbol looks like an inverted 3. So if you write 3, you invert it, turn it upside down, or you can also use this symbol. It looks like alphabet U, small letter U, and this on it. So universal set means a set that comprises of all the elements in consideration or of interest. Now, for example, let me take for example now. This is set. This is the universal set. This is the universal set. The universal set is the set of every student in FUT Minna, Federal University of Technology Minna, where I'm privileged to graduate from. Now, in the university, every students are members of the universal set. If be it students in engineering, be it students in sciences, be it students in environmentals and different departments in the school, or different faculties in the school. Now we have set B. Set B is set of students in engineering departments, and we have set C, which is set of students in science department. We have set D, which is set of students in education department. Now we have another type of set, which is subset and superset. Subset and superset. The subset is like in this case we have A. Oh, sorry, B. Let me change this. Let's use this. B is a superset. Is a subset of the universal set. Where is B? B is students in the engineering department, and B is the subset. This symbol here that looks like a C stands for subset. B is a subset of the universal set. The universal set, remember the universal set is all students in Federal University of Technology now. And F is not a subset. This means when you have a C like this and you have a slash on it, it means it's not a subset. It's not a subset of the universal set because there are no elements or there is no set that is standing, that is F here. And if you look at this one means that E, the universal set of students in Futmina, is a superset of A. Superset of, so let us change it to B. Superset of B, because there's no A on the set list. So it's a superset of B. It's a set that comprises of all the elements that can be in B. That is what. So that's another type of set, subset and superset. So we have the third type of set, which is infinite and finite set. An infinite set has no end, doesn't terminate. Like for example, the example you can see on the board, set N is a set of natural numbers. Natural numbers are counting numbers. So if you start counting from 1, 2, 3, 4, you continue to count, and it doesn't have an end. So this type of set, this set N, is called an infinite set. I also have a finite set. A finite set is a set that terminates, that has an end. For example, set 8. You say set 8 is factors of 12. So you can list out the elements of the set as 1, 2, 3, 4, 6, and 12. Terminates. This type of set is called a finite set. Now we have a null set. Null set is also called an empty set and a unit set. Null set and unit set. A null set is an empty set, a set that doesn't have any member or any element. For example, this is X, is a set of men having tails. So there is no men that have tail. So there is this set. X is an empty set. It's also denoted by this symbol that you can see on the board. You write a 0 and you put a slash on it. That's that's a null set. You cannot put this symbol into this curly bracket. If you put it in this, you are saying that this is a unit set. So it's either you denote it by this empty curly bracket or you denote it by this symbol here. Now Y is a set of a prime number and an even number. So a prime number and an even number. A number that is a prime number and is also an even number, and that only number is only one. That's 2. 2 is a prime number because it has 2 factors, and 2 is also an even number because it can be divisible perfectly by 2. So this is the fourth type of set that we have. We have the last type of set I will be discussing under the type of set, the complement of a set. Now, the simple meaning of the complement is any set, any element that, for example, let's look at this example so that you can understand it correctly. There is a universal set. This is a universal set, and the element of this universal set is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements in the universal set. And A is also a set of 1, 2, 3, 5, 1, 2, 5, 10, 4 elements in in set A. Set A happens to be a subset of the universal set because all the elements in A is in the universal set. So set A is a subset of the universal set. Now for you to now determine A complement. A complement is represented by this prime on it. This means prime. Put a small slash on it like this. It means prime. or this A raised to power C. It means A complement. Now A complement is 3 because 3 is not in A but is in the universal set. 4 is not in A but is in the universal set. 6 is not in A, it's also in the universal set. 7, 8 and 9. Also we have another set B, 1, 2, 4, 5, 10. 1, 2, 4, 5, 10. All these elements are also in the universal set. That means B is a subset of the universal set. Now B complement is 3 because 3 is not in B. 6 is not in B but it's in the universal set. 7 is not in B but it's in the universal set. 8 is not in B but in the universal set. And 9. So a complement of a set is the element that is not in that is in the universal set, that is in the universal set but not in the set B. In the set you are considering, that is a complement of the set. I hope you understand that simple idea.